Hi everyone, welcome to our talk. Today Ankit, Naik and me, Vedat Channel, will be talking about what is new on System Modeler. As a System Modeler team, our primary focus for version 14 series has been on developing and supporting the libraries alongside developing new features. We have also created many learning resources in this time. So if we look at the version 14, we see that we released the rotating machinery version 1, in which users, the library allows users to test their novel designs or identify faults in rotating machinery, such as turbines, motors, and drivelines. In version 14.1, we release another library, another version of the library for the aircraft library. So in this time, we added the features and reconstruct the library in a way that it became more user-friendly. And also we added unmanned aerial vehicles, which are the drones. So these are what we have done so far in this System Modeler version 14 series. So Ankit, can you tell us what other things we should expect as System Modeler users?
Right. Thank you, Vedat. Yeah, as you rightly mentioned, we have had a focus on new model libraries. And in 14.2 and looking forward, we are focusing on supporting a lot of new model libraries that will help our users to create models of their systems quickly. The libraries that are coming that we will be focusing today is OPC UA library version 3.0, the belt systems library, and the photovoltaics library. So those are the three libraries that we will focus in this presentation, and also we have specific presentations coming up in this conference. But there are also other energy related libraries that we are working on the background. And as you said, in this 14 series, we have also worked on on creating a lot of learning resources like study groups, custom LLMs, and MOOCs, as well as we are working on something called on a new Wolfram language feature that would help people in validating the requirements. So those are the key things that we'll be covering that we think would be very much beneficial to our users. Of course, we have done much more than that, but those are the key things that we will focus in today's presentation. Right. With that, let's get started with the new belts library. What is this belts library all about? Where it is used? Can you give us a quick overview of it?
Yeah, sure, Ankit. As you already know, the belt system are used everywhere, from like the fitness equipment to automotive systems. Like here we see treadmill for the fitness equipment in the first figure, and in the middle, like serpentine belt system for in a car engine, and in the third one we see another application for complex paper making processes. So those tools are used for power transmission and precise motion control. So in this library, in this new library, the people, the users, will get comfortable when it comes to modeling like a tensioner and dancer and web accumulator and open and closed loop belt system when it comes to roll-to-roll system modeling, while addressing the problems and coming with up the solutions to challenges like induced wear and tear and then the roller slippage. We have simplified and the advanced way of modeling a friction, and we have notorious vibrations. So they can also come up with system for the overload protection and inconsistent web tension. So here, for instance, we see a small web accumulator in which we have one unwinder and one rewinder. So in the animation, as you can see here, web is pushing forward, actually not pushing forward, the other role is pulling
The
pulling it to
paper.
the pulling the paper from the unwinder. And over time, all the dynamics, the metrics, the fidelity you are looking for, like the web tensions and the velocity change over time, and the designers can look at that. And also in other one, if you look at, for instance, here we are looking at web accumulator. It can be also calendaring process. So here we have a chunk of material which is heated over time, and in which we have like 10 rollers in between. So these rollers can be heated, and over the time, depending on the desired moisture content, the velocity can be adjusted. Then the people can see whether this dynamics the system runs at are sustainable in reality. So those type of questions people can answer using this library.
Right. And I assume all this animations they come built in with the component,
Exactly. Yeah.
right? And
They
this is
come
a
for
free
free.
library, of course, right?
Right.
Yes, great. And with that, we do have a specific presentation on this tomorrow. So people who are interested in modeling this kind of systems and looking into these components at a deeper level, they are welcome to attend Vedat's presentation that is scheduled for tomorrow.
Yeah, I will be waiting.
Okay, and moving on from belts, we have been focusing a lot on the energy, on supporting uh, various third-party energy-related libraries as well. In the past few conferences, we have had presentations on how to model power grids, modeling power systems, and and such. And in this conference, we have a focus on modeling PV panels. And for that, there is a third-party library by the name of photovoltaics that we have recently supported, and we will be presenting a more detailed uh, system, a complex system with this PV module, with the use of this PV module photovoltaic library. And that presentation is just after this talk, where I will use my own home in Linköping. And for 30 different PV modules, I will try to model how much solar energy I can produce. And then I will try to answer a very difficult question that is PV sufficient for to meet my energy demand? And if I can get the payback period in a quick time, like I want to understand like how the PV would perform at my particular house. And to answer that question, I have used this photovoltaics library. And here you could see with using the built-in components from this library, I could simulate the solar energy in any given day. And I could also simulate the annual solar energy production that I might expect at my particular location. But I will go into more details, and that presentation is just after this, where I will be modeling uh, uh, my solar profile at my location, along with modeling energy demands of my house.
So
Right.
Ankit, are you claiming that I will be able to answer whether I should invest on solar panel after watching your presentation?
I think I'm not claiming anything. I will just provide you the right tools. Like I will provide you with a workflow notebook that you can use to predict the energy demand of your particular house, as well as you can use that notebook to predict the solar power that you could expect. And then it's up to you to make that decision whether you want to invest or
Okay.
not. Right.
Yeah.
Okay, Vedat. The next thing that we will be covering today is the OPC UA library. For people who are unaware about OPC UA, if you can give a quick background and just talk about what this library
Right.
is all about, it would be great.
Right. OPC is Open Platform Communications, which is a communication platform. So this library help us read what is happening in different devices. And so, for instance, when we start reading the data coming from the system using a server, we can do many things with that, such as like the post-processing in Wolfram language. We can just use that data, collected data, to create a data-driven system like a neural net. That is possible. Also, we can do system analysis, like we can just monitor the system whether it behaves as expected. Also, we can use this system, this data, to create the neural net. It can be a controller, for instance. If we look at the example below, Ankit, so here, for instance, we have a neural net which might be designed by using this data, this collected data, and gives the control input to the system. So this thing help us to connect to platforms.
Right.
What else can be done in this version of the library? Security and authentication. So now the communication protocols are more cyber secure, I would say. So it will be it will be more cyber resilient. And also, when it comes to error handling, you will have freedom to handle this error in system modeler as you like. So what else can be added for this feature, this version of the library is the scalability. Instead of reading just one array, now you can read arrays of data in which you can have more models connected to these servers in just one system modeler model. So yeah, those are the common improvements and the features we added to the library
Right.
in this version.
Right.
Maybe you might have something I'm missing. I
Yeah,
get
so
you.
yeah, no, I think Vedad, you covered it perfectly well. So basically, this library provides the like blocks that you can directly drag and drop, and then you can connect to your OPC servers, and you can read and write signals. So you can just start communicating with your industrial equipments by quickly assembling a model, and you don't need to know all the details. So those details have
Mm,
been taken care of. And of course, this is also a free library that people can use. Right. That was
yeah,
all Vedat.
yeah, that's great. What else we have? Yeah, learning resources, Ankit. So what can you tell us about this?
Yes. So far, Vedat, we covered three different libraries, and we are focusing on releasing those three libraries, particularly with version 14.2. And we have specific presentations for each of them where we go into more details into the workflows and into the components and such. But apart from libraries, as we said, we worked on creating a lot of learning resources. And one learning resource which I particularly wanted to share with our viewers, where you and me, we both were involved, is this study group that we did on guiding principles for modeling and simulation. So basically, this is a 13-hour uh, like
Work and recording.
recordings where me and Vedat, we start with very basics on how to use system modeler. Then for each session, we noted down what are the best practices when we during our modeling journey. Like we should start small, start simple, learn from other domains, don't neglect interactions, and so on. So in this long video course series, we have we have tried to use non-engineering related problems, like problems that are relevant to our day-to-day life. Like we have models on global warming, we have models on creating music, and also we have modeled the election dynamics. So this is I would highly recommend people to watch this if they want to understand how to use system modeler, and also if they want to brush up uh, like modeling principles that would that help them in the modeling process. So that
Right.
is something that we created. Um, and of course, you can watch this recordings. Uh, Along with that, a lot of times we get a lot of questions like, how do I create models with System Modeler? Like, how do I create my custom model or custom library using System Modeler? And uh, and to make that process easier, we created a custom LLM. So basically, we created a custom GPT. That is, we trained the GPT on specialized content for the Modelica language. So people who are new, Modelica language is the language, it's the open standard language that is used when you write your own custom models in System Modeler. And now we have a custom GPT that you can use uh, as a uh, that you can use that would help you in creating models quickly. It can answer basic Modelica questions like what is the syntax for a for loop, or if you happen to look at one of the code snippet in System Modeler and you do not understand what that code snippet is all about, you can just copy it and paste it in Modelica Mentor, and it will give you a summary of how the declaration is taking place, what does the connect equations mean, and those kind of questions it will be able to answer. Of course, it is not perfect, but if you're trying to uh, start creating your own models, it would really accelerate your modeling process.
Right. It is also still evolving, right?
Yes, it is still evolving. We're trying to add more examples to it so that it gets trained on specialized content. But yeah, it's a start.
Yeah.
And finally, for people who are interested in learning about electric circuits, also for people who are interested to, to learn about music, we have combined music and electric circuits together in a MOOC that is available already. And one of our colleagues, Leo, who's very passionate about music, he has created this tailored course where he will teach you the basics of electric circuits along with introducing you to amplifiers, and then he will go into the details that are needed to create music using analog synthesizers. So this course is already live that you can directly go and have a look. Finally, a sneak peek to the future uh, on something called validating requirements. So Vedad, if you can just give a background of what these requirements are and what are we working on?
Yeah, right. So, Ankit, we have been working on this in a scenarios. For instance, you know these gimbals, right? Camera stabilizer, which don't have any active controllers. And when you start taking shots, you might see that, oh, the quality is really bad. Then you want to add some controller to that. So in that type of camera stabilizer, you just want to know whether it's works as expected with a better quality. You might have some criteria saying that, okay, it shouldn't be exceed 2 centimeters. The camera should not move more than 2 centimeters up and down in both direction. But then it is really hard to test thousands of scenarios when it comes to different type of disturbances. For instance, you might be recording in a windy weather, right? It has a different characteristic when it comes to disturbance. So instead of looking each of them, what you do instead, you use validate requirements, system model validate, to check those bulk of simulation results and see whether your controller works as expected. So for instance, in this scenario, what we did, we just create those scenarios saying that the uncertainty will be that many and we will run 50 of the simulations. And after doing that, we are just using the system model validate functionality to test whether our camera position moves back and forth 0.2 centimeter, 2 centimeters. And then it tell us, oh, okay, there is only this chance of the success probability. I mean, it says that 62% percent of the simulations are staying below the limit we set, but the remainings are failing. As you rightly show here, for instance, from the one scenario, we see that it is just exceeding the green line you plotted. So for that scenario, the camera performances are not as good as at least you would like to have.
Right. That's great. So you mean that if I have a model and I want to test my model for various uncertain inputs, and I want to see if it stays below my design limits, so rather than creating a lot of code in loops that goes through thousands of simulations, I can just use this function and then give my criteria. And then it would automatically create those simulations for me and then give me the compiled success or failure probabilities. And
Exactly.
ideally, I should expect 100% success.
Yeah.
Yeah,
As an engineer, to be on the safe side.
yes. Okay, Vedat, and also we have a specific presentation by our colleague Sergio, and I think that's on tomorrow.
Right.
Right. Uh, right. So those were the key updates that we thought would be interesting for our for system modeler users. But there are also, and we have specific talks focused on the things that we covered in this talk. But apart from those, there are other talks on system modeler in this conference as well, which are really interesting. One presentation is on modeling cost estimation for civil aircraft that's planned for today. And then we have another presentation on modeling space-based solar power efficacy. That's tomorrow. And on Friday, we have a presentation on how to optimize pumping stations using both Mathematica and System Modeler. And we would urge everyone to, if you are interested in those topics, to please go and view those presentations. Right. Okay, Vedat, is there anything else that you plan
I
to add?
don't think so. No, I guess we covered all the things we want to cover. Yeah.
Yes. Great. And of course, if you have any questions now, you can put it in the chat and we will be happy to answer. Yeah, thank you.
Yeah, thank you.
Bye.
Bye.